What's going on, and welcome to this crowded board. In today's video we're going to go over Docker containers and the exploitation of Docker containers. At the very first, let's first understand what is a Docker container and what's the difference between the Docker and the virtual machines. So first, Docker containers like C1, C2, C3, they run inside a Docker engine. They are separated from each other and are isolated. Though they can communicate, if you want to configure them, they can communicate with each other as well. The key difference between Docker containers and virtual machines is that Docker containers, they use the CPU and the RAM of the main operating system. There is no any sort of allocation of the CPU or RAM of the main OS to the containers. But in virtual machines, if you got a CPU and RAM, let's say 16 gigabytes and 8 cores, you can take portion of these specs and allocate them to virtual machines. Say virtual machine 1 has 2 gigabytes and 2 cores. Hence, the host machine will end up with 6 cores here and 14 gigabytes. So the virtual machines are actually, sharing the resources of the host, but in a different fashion. They take up the resources. But in Docker containers, they share the CPU and RAM without any kind of separate allocation. That's why Docker containers are more lightweight, faster, and more flexible. Additionally, Docker containers are used for security. As you can see in Docker 1, C1, in order for an attacker to sneak to the operating system, they need to break out of the container in order to sneak to the main operating system. That's the main feature of Docker containers. In today's video, we're gonna do a scenario where we will pivot through different containers, online and offline containers, and see how we can break out of these containers. We will use a machine from HackTheBox called HackTheBox Ariekei. So Ariekei is a machine from HackTheBox where it best demonstrates the concept of pivoting between containers. In the scenario here, we got 3 containers. We can first navigate to the machine on port 443. Once we navigate to the port 443, we will see a way to get a shell. Once we get shell, we will be landed on calvin.ariekei.htp, which is the container that is online. Okay. Now we will find out later that there was a web application firewall that no matter what we do, it actually redirects us to the Calvin container. And actually it is protecting an offline container called beehive. This is the offline container. We will see that in a while. Don't ask me why and how. And don't be be patient. We will explain how. So basically, the application firewall here is actually protecting the beehive and preventing connections or preventing us from directly exploiting the shell shock vulnerability here that we will uncover. And it makes us land at the Calvin. From Calvin, we will be able to view the network configurations of the containers, and we will find out or uncover another container called Ezra Ariekei. Ezra Ariekei actually sits in between Calvin and beehive. It has 2 network interfaces. One is online and one is offline. Through Ezra, we will do something called SSH, local and remote port forwarding, in order to send the commands to beehive. It makes sense. We cannot access beehive. It is offline. So we need some sort of local port forwarding. Since we got SSH access on Ezra, we will be able to do that using local and remote port forwarding rules. Using the local and remote port forwarding rules, we will be able to execute a shell shock vulnerability on beehive and give us shell on beehive. Once we are on beehive, we will find private keys. The private keys here will enable us to log into the last or take us to the last step on port 22. And from there, we will just do normal privilege escalation. All right, let's do this. So let's close my board. And now I'm going to skip, guys, the typical steps of directory search, directory repository, finding the directories. I'm going to jump right to the point. So I'm going to show you the nmap scan results. Is the host down? Seems like the host is down, right? So we're going to need to... it's actually online. But this kind of work for some reason. Alright. Anyway, the machine needs a bit of reset because it's actually a lag machine. If you are doing the machine for the first time, expect some delay or lag on the machine. It's very actually expected. Most of the retired machines are like that. I don't know why. So anyway, also don't forget to add to your host file the followings. So this is the IP of the machine. We add the main host name, and also we add these hosts as well, beehive and Calvin. You will find these once we access the machine or access the IP on the port 443 through the certificate details. Let's see, is it online now? Okay, online. Now we're trying to access 6.5 and it's spinning site maintenance. Again, I'm gonna tell you how I found the host names, more information, view certificates, and here are the host names. Now, with some sort of directory search, you will find that there is a directory called CGI bin stats. It could be here or it was on, let me recall where it was. At Calvin, I guess. Let's take Calvin. Try this one and try this one. Server. Look at this one. So you have to put slash here. Again, the machine is laggy, so I'm gonna make sure the VPN is working. Oh, I don't have VPN open, so sudo open VPN. Desktop. Okay, connected now. So advanced, accept, servers not available. And we're gonna need to, let's see. So I'm getting servers not found all the time. Yeah, this one. So slash CGI bin slash stats on the main host. You see what seems to be the output of bash script. It displays the time and date of the system. Also it displays the bash version. Judging by the bash version, we got 4.2.37, which means we can execute shell shock vulnerability, exploitatory. So we can't do that, unfortunately. I'm giving you now, guys, a brief, right? I can't go to the details. That's not the point of this video. But you will find that the reason for this is the existence of a web application firewall. If you turn on proxy intercept the request to this host, you will see in the response headers the indication of application firewall. All right. So if we have a firewall, what can we do here? We're gonna need to find another way. So there is a directory on. Let's copy this. If you go to Calvin /upload, again, all these directories, you'll find them by running directory search. Upload. If the machine is acting laggy, guys, make sure to disconnect and connect again. It will speed up the process. Yeah, so here you have upload image. Looking at the title, we have image converter, and previously there was a vulnerability that affected all image converters on the web. The vulnerability allows to upload a file with the extension .mvg, the extension used by image converters, namely ImageTragick. And after uploading the file, you will get shell. So how this works, this page talks about this. Inside ImageTragick, the vulnerability called ImageTragick, and it actually affected image converters that use ImageTragick to convert and process files. So basically, what we need to do here, we need to upload an image with the extension MVG and open a listener on my machine. So what happens here is this. Let's open new. Okay, so clear cd desktop cd Ariekei. Okay, ls. I have created a file called POC-MVG. This is the contents. So this is the content that goes for MVG files, and here I put a payload. You can find all of these payloads here. Example of these payloads. So this one actually returns a shell on port, bash shell on port 444s. So I'm gonna start listening on this port, and I'm gonna open or upload this one. Open, upload. Let's take a look now. Exactly. You may see me now disconnect and connect multiple times because the machine is laggy. I hope you understand this. So refresh, send, and now we landed on the first shell. So that's the very first step. Now the actual objective of the video starts from here. So right now we are in a Docker container, root at Calvin app. If you type ID, you will see that you are the root. Unfortunately, I have to do this multiple times. So yeah, so root, but you are actually the root inside the container. So as I said earlier, we need to break out of this container. First, let's review the configuration of this container and understand more about the network. cd ls, go to common. Now we have two directories, containers and network. Go to network, ls, and we have two files. This one is actually a script. Let's cut the script to display the contents. Okay, so I have two portions. The first one, create isolated network for building containers, no internet access. The next one, create network for live containers, internet access. So we have two networks. Okay, the first network is offline, 172.24. Just take a note in your mind that the offline network has 24. The online one has 23. So that's the first item in this video. We have to understand what are the networks that cover the containers. So most probably, since we are at Calvin and Calvin network is online, we are at this subnet. So the first step is to get the IP address. If config won't work, because if config doesn't exist on the current container, so we're gonna have to cat or cd to extract it from prog nets, which contains all of the adapters, etc. network information. So since we are at 172.23, I want to grab the IP address. We're gonna use grep and a pattern of 172 since it's the start of the network address, and then we specify the directory, disconnect, connect back, resend, one more time. Okay, so what do we have here? Let's take a look. We have some addresses. We have this one, 172.23.0.11, and it resides in the same network here, which means this is the IP address of the current container. Okay, right now we got information about the network architecture of the containers, and we got the IP address of this container. What's next? Let's now review more configurations about the containers. If we cd back ls, we have containers, cd containers, and we have all of the 3 containers we have talked about at the very first of the video. We have also the application firewall talked about. So right now we are at convert live. How do I know this? To just, if you cd to convert live, ls, and if you cat the Docker file, from internal HTTP Docker ImageTragick. So ImageTragick is the actual service we exploited, which means we are at convert live. You can also cat start.sh, okay, and see, this is the IP address of the current container. So we are at container live. Let's cd back now and see other containers. Bastion live. Who is Bastion live? Oh my goodness. A typical HackTheBox machine. Okay. ls cat docker file. What is this? Run echo, change password. So these are credentials actually we'll use later. Just take a note of these credentials. If you cat start sh, we see this is the IP address of the Bastion container. So you may need to take note of all of these IP addresses if you are doing this for the first time. Now we cd back and we go to block test. I guess block test is the offline one. Cat start, and this is its IP address. Take note of the 24. The 24 actually is the offline network, and this is the IP address of the block test. It is the beehive, as you can see. So right now we have enough information about the architecture and the addresses of the containers. Let's now see how we can now move from Calvin into Bastion Live. Bastion Live has the IP address of 124.0.253, which is actually offline. But again, I told you guys that Bastion Live sits in between the convert live and block test. So it has an offline portion and an online portion. We're gonna need to pivot to this, which is ISRA Ariekei HTTP. So how to do that? Again, skip all the guessing parts. Directly go to the solution. I'm gonna again, oh my goodness, this one all the time. Okay. Okay, ls cd come on. It's time to reconnect. If you have one explanation, guys, of why this is happening, just please enlighten me. ls-la, we have .secrets here. If you go to .secrets, we have Bastion key, which means we have now the private key to connect to the Bastion container. All right, skipping this, you can just copy that to your machine. New tab, let's connect to Bastion now, or ISRA, sh dash I ID underscore SA, and then root at, yeah, this is it. It's on port 1022. You can try on port 22, it's not gonna work. So connect. If it didn't connect, refresh here and reconnect to the VPN. Okay, so right now we are root ISRA, at root ISRA now. ID, root, back. But right now we are at ISRA, which happens to be, as I told you earlier, it is this one, the one that sits in between. In between who? The block test and the convert live. We are at Bastion live right now, and we saw that Bastion Live has two portions, offline and online one. Let's take a look at the IP address. Just give me a break, man. Give me a break of these machines. Okay. Fconfig. Alright, two Ethernet interfaces as expected. One connects to the online network and other one connects to the offline one. We see Ethernet has an IP address of 172.23.253, the online one, and this IP on the offline network. So we are here right now. So we want to move now to this network, which happens to be at the same network of the block test container. Block test container has the IP address. Let me remind you of the IP address. It was this. In order to reach this, we have to move to this. Okay, what do we do now? We are at ISRA, so what do? We can have two methods. We can either download, before download, let me mention one thing. If you try to ping now, give me another break. Oh my goodness, I need to disconnect multiple times. Okay, so ping, try to ping this guy. You will be able to do this, you see that. Why? Because it has the Ethernet 1 interface, which happens to connect to the other network. Okay, what do we do now? We have two options. We can go to the shell shock URL. Let's see where I put this. So do I need to go to history to grab the URL, or let's see, shell shock. You can download this now and execute it from ISRA against this IP, and you will get a shell as www. Or I prefer the other way around, to create local and remote port forwarding rules. The thing that we hate the most, but it's actually the preferred method, because you will be able to execute system commands starting from within your own machine here. So this is my machine now. I'm going to create one local remote port forwarding rule that will forward connections from my own machine, okay, to what? To ISRA, and ISRA from ISRA to this. Okay, remember that this is the IP address of the beehive container, which happens to run a web server on port 80, vulnerable to shell shock vulnerability. But it was protected by the firewall running on port 443 with the HTTPS. So what do we do? Create now local remote port forwarding rule. Let's see here where I find the comments. I don't want to make mistakes. So forward, forward. Let's see here. Forwarding. Okay, now we got the sorter. So here we go. -n -l and provide the addresses. Fine. So sh-l. This is it. How it works. We have, let me first specify the IP address. So here goes 000. Okay, what happens now? I forward connections to port. I open a connection. I open up a port 340 on what? On ISRA, to forward all the connections that come to port 440 to the beehive on port 80 through my machine. That's how it's gonna work. If you want, you can cancel this. No need to mention this anyway. So now enter, and right now I'm using the current connection I have to ISRA on port 1022. Of course, you're gonna need to disconnect and connect to make sure, or to make this work again. Oh, I forgot something. The private key. So -i ID. All right. Do we need to refresh again? another tab, while this is working, I will create remote port forwarding rule to forward the connections from the beehive to my own machine, because I will create a listener here. So what I'm going to do, I'm going to do sh-i id underscore rsa, and let's do some modifications on this. So the port I will select is whatever, it could be 441, and here it would be my local machine IP address, and there here the port that I will create a listener on. So it's going to be 4446. Okay, now what's going to happen here, the bastion or the beehive will be able to forward connections, okay, to my own machine on port 446 through port 4441. Let's enter. Let's see here if this is gonna work or not. Okay. So right now we created the local port forwarding rule. Next, let's wait for this to work. All right. While this is working right now, we will be able to send the payload for exploiting the shell shock vulnerability. So curl, this is the payload. Let me go over the payload. This is the proof of concept payload, by the way. And here, what I would like to execute. So take a look at this. Here, I open a listener or open a bash shell on what? Or a listener actually on 172.24.0.253.4441. Let's go back and see what is 441. 441 actually is the port I selected here. Through this port, the beehive machine, okay, will be able to forward connections. Okay, once the connections arrive at port 441 on the bastion, it will be re-forwarded back to my machine on port 440. So next we have the part where we define against which we would like to execute this exploit. So I'm setting here localhost. Why localhost? Because I have one local port forwarding rule, right? That forwards connection to the beehive machine through port 440. I specified the port 440. So any connections coming to 440 will be forwarded to the bastion host, not the bastion, sorry, the beehive on port 80, which happens to run the vulnerable website or servers to shell shock vulnerability. Connection closed by port. So the remote, what is this? So this didn't work because I didn't specify the correct syntax. So here I have -r for remote forwarding. Again, we're gonna need to refresh. Right now the remote port forwarding rule worked. So right now a listener here on port 446, right? As you can see in the remote port forwarding rule, I use port 446 on my local machine to listen for incoming connections. Okay. So let's see here. And now we execute the exploit. As you can see, we receive now the shell on beehive. So right now we are inside the offline container. Okay, ID. Yep, one more time. Okay, so we are dub data. Long story short, we have to find the SSH key. Okay, so if we cd to home, we will have a directory called Spanish Dancer. ls. Now you got the user flag. Use the long list. You will find that there is an SSH directory to which we cannot have any sort of access. Which means we cannot use the private key. Remember, At the very first, when we were at the online container Calvin, we found pair of not SSH. I was about to say SSH. It's not SSH. It is. Let me check here. Where was the credentials? Yeah, here it is. Use these to elevate from data to root. Once you're able to do that, you will get access to the private key here. I'm not gonna do this now. You can do it your own. So next, you will get the private key. I called it ID RSA Spanish. ID cat ID RSA Spanish. The private key is encrypted, which means if we attempt to use it to connect to Spanish dancer, it will ask for passphrase. That's why we use SSH to John here. So I use this actually to convert it into hash. Then use sudo John, as you can see, to crack the hash. The password will be purple. I think I need to run this. So the password is purple one. Now we take this password and connect to the port 22 now using Spanish dancer. Why Spanish dancer? It was the name of the user to which the SSH key belongs. So enter, use purple one. Yep, refresh here. Enter passphrase, purple one, and we are in. Now your last step is to figure out that the Spanish dancer is part of the Docker group. And actually Dockers need, some users actually need to perform some operations on the Dockers. And since Dockers actually run or perform the commands as root, we cannot just make any user execute commands as root. That's why we add the users on the Docker group. But actually this has proven to be not the correct method for security. Why? Because now, right now we can use this fact to dump the contents of the root file system using an exploit. So Docker, yep, one more time. Seems like it's more important to know that the machine is lacking than to do the machine. So let's see, yeah, it worked now. Docker run -v, and right now we dump the content of the root file system to a directory of our own. Let's say root sp, meaning root Spanish, -i -t, and here comes the image name that we would like to use as template. So the image name is, you can find the images by using docker images. Here are the images. We use the bash as an image template. So docker run -v. In the middle of the command, you will have to refresh one more time. Okay. So mount the root file system to a directory of my choice. It's gonna be root sp. I told you it's root Spanish and -i -t. Oh, come on. It hasn't been 2 seconds. A typical HackTheBox machine that resets every portion of the second. Oh my goodness. Oh my goodness. So bash. Oh my god. -t. Bash id root cd root ls cat. Oops, nothing. Oh, cd to root sp, because I mounted the root directory to my root sp. Right now root. Now we have, and that was your flag. I hope you guys enjoyed this Docker containers journey. I hope you find also the video informative, and I hope also you find the learning experience to be great, and see you later.